Hey everyone, so I just wanted to jump on quick and talk to you about all of the different ways that we've learned to solve exponential and logarithmic equations. I know it seems like we've looked at a lot of different ways, but there's actually just kind of like 4 different types that we've looked at, okay? So I'm just going to highlight some of those different types and how we solve those in this video. All right. So remember exponential functions. Exponential functions means that there's an exponent in the equation. When you first get an equation and if it has an exponent in it, then it is considered an exponential equation. And there's 2 ways that we learned how to solve exponential equations. The first way was to check and see if we could get the bases to be the same. Because if we were able to get the bases the same, then we could set those exponents equal to each other and solve from that way. So if you could, try and get the bases the same and then set the exponents equal to each other. The next way we learned how to solve exponentials, and this is when we couldn't get the bases the same. So there's no way I can get 7 and 3 to have the same base. When we couldn't get the same base, that's where we took the log of both sides, the common log of both sides, and then solved from there. So remember, we moved our exponents out front, and we approximated what log of 3 actually is. Okay, so those are 2 ways to solve exponential equations. We get the bases the same and then set the exponents equal, or we could take the log of both sides. All right, so that was exponential. Then we also talked a lot about logarithmic equations as well. So remember, a logarithmic equation is when you look at the problem and we see a log in it. And there's really 2 ways we had to solve logarithmic equations as well. So the first way was to do a log rule. Yes, Hayden, honey. Wait. Okay. So when we did a log rule, that was when we only had one thing, or not all of the things have logs on it. So you see here we have a log equal a number. So we went ahead and did our log rule. Other times when we did our log rule is ones like this here. So again, notice not everything has a log attached to it. So this is where we first had to isolate the log. We wanted to get the log totally by itself. And then we did the log rule. Other times we did log rules as like this last problem. So again, notice not everything has a log attached to it. And to solve these ones, we had to first combine. We had to use our properties and combine that, condense that into one log. So remember, it looks like we have addition here, and we know addition really means multiplication. So we combined that with multiplication, and then we did our log rule. So we do log rules when not every single piece has a log attached to it. Okay, and then the other way for logs was when every piece did have a log attached to it. And when every piece did have a log attached to it, we were able to set our arguments equal to each other. We also looked at problems like this as well. So notice everything has a log attached to it. But remember, before we could set our arguments equal to each other, we needed to condense this into one expression. So remember, subtraction really means division. So we could rewrite this by dividing our logs. Okay? And then once we did that, once we combine it into one log, we can set our arguments equal to each other. All right. So there is a quick overview. I'm going to show you the whole thing, maybe, of all of the different ways we had of solving logs and exponential equations.